So what we're going to do right now is we're going to look at reactions and predict what the entropy change is going to be, positive or negative. So before we start here, there's a couple of general rules that you need to be aware of here. If we're taking a look at in the entropy train, a solid is going to be less entropy than a liquid, is going to be less entropy than a gas. Also, if you have 1 mole of something versus 2 moles of something, the entropy is going to go up as well. So essentially, an aqueous kind of finds its middle ground in here with where liquid is. So when we're comparing, and also really, really important, when we compare a gas to a liquid, this is incredibly more disordered than a liquid. So I could have like 3 or 4 moles of liquid, but only 1 mole of gas, and that 1 mole of gas is going to be way, way more disordered. So let's take a look at what they've given us here and take a look at the equations. So they start us over here on this side. It's always we're comparing what the products are to the reactant side. So if we take a look over here, we have 1 mole of gas. And the reason we know it's 1 mole is that there's a coefficient of 1 in front of it. And then we have 1 aqueous. But the real thing we're caring about here is we have 1 mole of gas. Over here, we have 1 mole of solid and 2 moles of aqueous. Remember our hierarchy over here. It doesn't matter that I have 2 moles of aqueous here and 1 mole of solid here. Over here, we have 1 mole of gas. Therefore, no matter what, it's going to be way, way more disordered. So this side over here, we have a much more disordered reaction. Now let's take a look at the next one. So over here, what do we have on this side? We have a solid, and we have 2 aqueous moles. Over on this side, we have 1 mole aqueous and 3 aqueous. So essentially on this side, when we're comparing, we have 3 aqueous on one side, and you have 2 aqueous and a solid on the other side. So we're essentially having a combination of these two over here. So overall, this side over here is going to be less disordered than this side, because if you take a look, here we have 2 aqueous, 1 aqueous, and I want to erase this mess that I made over here. And over here we have 2 aqueous and 1 solid. So 3 aqueous on this side and 1 solid and 2 aqueous loses. So overall change in entropy on this side is going to be negative. And let's look at the last one here. Over here we have 1 mole of aqueous and 1 mole of aqueous, and over here we have 1 mole of solid. So over on this side we essentially have 1 solid, and here we have 2 moles of aqueous. I've gotten lazy with not writing moles of aqueous in here. So we're going from 1 solid to 2 aqueous. Therefore our change in entropy is going to be positive. Hopefully this has helped.